Hello friends, welcome to CEC Live Lectures. Dear friends, today in this session we are going to talk on cloud computing once again, as we have promised that there is a lot more of content for you. So friends, taking your concerns into account as well as per the subject mapping of cloud computing, today we are going to talk on load balancing, algorithm and resource optimization in cloud computing. And for the discussion on the topic, we have with us in our studios Dr. Mansaf Alam. Dr. Mansaf Alam is an eminent professor, and he is an associate professor in Department of Computer Science, Jamia Millia Islamia. We would like to tell you all that he makes continuous efforts. Through him we always get in-depth knowledge on various issues of computer sciences, and we know that you students are continuously taking benefits of his teachings and his experiences. Friends, we also know that you might have lots of questions in mind and you want your questions to be answered through Dr. Mansaf Alam. So, for talking to Dr. Mansaf Alam on today's topic, do call us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. You are requested to call in the last 10 minutes of the lecture only, and please ask questions pertaining to the subject only. Now, I would like to welcome our guest, Dr. Mansaf Alam, once again. Hello, sir.
Thank you, ma'am. Hello, friend. Good afternoon. Myself, Dr. Mansaf Alam, Associate Professor, Department of Computer Science, Jamia Millia Islamia. Today, I will deliver load balancing algorithms and resource optimization. This is the 14th lecture in cloud computing series. Before it, I had discussed about the load balancing techniques, general things about the load balancing, how to balance the load among the server. That all was discussed in the previous lecture. In today's lecture, I will focus only on the load balancing algorithms as well as the optimizations technique for the resources. So let us see here what are the various types of standard algorithm for load balancing. That is, first one, round robin algorithm for load balancing, second one, weighted round robin, and third one, least connections, fourth one, weighted least connections, and the random. These are the 5 standard load balancing algorithm in cloud computing. Let us start from the round robin algorithm. This is the general term round robin, and that is generally used in the operating system and the time sharing system. Let us see first what exactly the round robin scheduling. So, round robin scheduling is used to schedule the resources in the computing. Let us see here the concept of time sharing system. Suppose you have one CPU and more than one job you have to process it. So, the job will be processed one by one. Let us see one example, 5 jobs and one CPU. So, first job will be given to CPU 1, and at that time a time slot is decided, that is known as the quantum, that is 10 to the power 10, or you can assume 10 seconds. If you are assuming the 10 second will be given to the first job and then the next job. So let us see in the example, you have a one CPU and the 5 job to be processed. The first job will be given to CPU for processing and time allotted 10 seconds. As soon as 10 seconds is expired, the CPU will take the second job and 10 seconds will be given to the second job. After 10 seconds, it will transfer the CPU to the third job and 10 seconds will be given to the third job. And as soon as the 10 seconds is expired, then it will rotate to the fourth job, and fourth job will be allocated to the CPU, and CPU will give the 10 second. After the 10 second, it will be given to the job 5 will be given to the CPU. CPU process the fifth job, and after that all the jobs in a queue is completed. Then the CPU will route to the again on the first job, second job, and third job. So this is the concept behind the round robin scheduling, and this is the most popular round robin scheduling used everywhere. But now how can you use this round robin scheduling in cloud computing to manage the requests? Let us see, understand it with the help of animations. Now let us see here the scenario. The requests are allocated in round robin fashions, and we have two servers, server A and server B. So let us see here server 1 or server A, and then let us server B. So now first you have to connect this server so with the load balancer. So here there are three components, server A, server B and the load balancer. Now you have to connect these two servers with the load balancing or load balancer. First use the wire here and next wire here, and then connect these two wire with the third wire and then connect to the load balancer. So this is the connections between the load balancer and the server. So among server 2, 3, any type, many more than two server may be connected with the load balancer, but in this example only two server, that is the server A and server B, connected with the load balancer. But now let us see, there are several client or several requests coming from some places to allocate the server for processing the data. Let us see some request. Let us request 1, and that request 1 is connected with the load balancer. Then take the second request, that is connected with the load balancer, and the third request you can again connect with the help of a wire to the load balancer. Then the next request and again connect with the load balancer. Fifth request connect with the load balancer and take the sixth balancer. So this is the diagram for the round robin scheduling or round robin algorithm. That means more than one request are connected with the load balancer, and load balancer is connected with the more than one server. But in this diagram, let us see the scenario. I have shown you with the help of animation how to make the connection of it. There are two servers, server A and server B, and you have 5 requests that all are connected with the load balancer. And let us see how this load balancer allocate the request to the particular server. Let us see here the request 1, whether request 1 will be allocated to server 1 or server B. Request 2 will be allocated to server 1 or server 2. So you have to use some techniques to allocate the incoming client request to the server. Let us again see and understand with the help of a animation. Let us see first one. Now you have to give the first request to the particular server. So just click, the first request will be given to server 1, and the second request will be given to server B, and the third request again will be given to server A, and fourth request will be given to server 4, and fifth request will be given to server A, and sixth request will be given to server 6. In the first inning, in the first round, the requests from 1 to 6 are allocated, and out of 6 requests, the 3 requests allocated to server A and 3 requests allocated to server B. So for server A 1, 3, 5 and server B 2, 4, 5, that all requests are allocated to the server A and server B. Now the scenario, this is the first round. In the next round, suppose new requests are coming in the queue, and then you have to again allocate it to the particular server, server A, server B. So let us assume here new jobs, new requests come, that is 7, 8, 9, 10, 11. So now you have new requests arrived, that is 7, 8, 9, 10 and 11. Now you have to allocate it. You have to allocate the server to the particular incoming jobs. So suppose you have here 7, 8, 9, 10 and 11, and now you have to give the 7, whether 7 will be given to server A or server B. Let us see. The first, both server having the equal load, then the server 7 will be given to server A, and 8 will be given to server B, and 9 will be given to server A, and 10 will be given to server B, and again 11 will be given to server A. Now this way you have allocated the coming request to the particular server and distributed the load among the server A and server B. So this technique is known as the round robin. So many rounds after it, maybe another round, maybe new job arrive, and then you can again allocate the incoming job in the round robin fashion. So now let us see, for the third round, suppose a job 12 will become. So the 12 will be given to whom? Server A or server B. So you can give the 12 job to server B, and then 12 job to server B, and 13 job to A. In this way you are allocating the job to the particular server. So this mechanism, this algorithm is known as the round robin scheduling algorithm. Now let us see what are the benefits, what are the various advantage of it over the other load balancing algorithm. So this algorithm is very simplest for distributing client requests across a group of users. So if you have a group of users that are going to request it, then it is the very simplest way for allocating the request to the server. So you can say here a group of server that request across distributing the client request across the group of server, then this can be implemented. It is the simplest one. And next, in case of down the list of server in the group, then the round robin load balancer algorithm forward a client request to each server in turn. The key benefit of round robin load balancing algorithm is that it is extremely simple to implement. It is easy to understand. In the short about the round robin scheduling, the round robin scheduling algorithm is the simplest for distributing client requests across the group of servers, and in the case of down of any one of the server in the group, then the request will be rounded, given to other server with the help of load balancer, and load balancer forward the job from the failure node to the active node. So in the case of any failure of the server, the request assigned to that server will be forwarded to other server which is actively working. And the key benefit of round robin load balancing scheduling is that it is extremely simple to implement, and it is also easy to understand. So this all about the round robin algorithm. Friend, let us move to the next load balancing algorithm, that is known as the weighted round robin algorithm. Means in the round robin algorithm, some extension of round robin algorithm is known as the weighted round robin algorithm. Means simply you have to assign the weight for each server. So let us see with the help of a diagram about the weighted round robin scheduling. So the requests are connected according to weight of the server. Let us see here again, there are two servers, server A and server B, and server A having the weight 4 and server B having the weight 1. That means you can say server A is greater than server B, means the capacity of server A is higher than the capacity of server B. So capacity of server A means CPU capacity, memory capacity, other capacity of a server, that in all respect server A is greater than server B. So processing capability of server A will be higher than the processing capability of server B. So according to the capability of the server, incoming requests are allocated for the processing, and load balancer responsibility to allocate the incoming request to the particular server. So let us see with the help of a simple animations for the weighted round robin scheduling. So here in this diagram there are two servers, server A and server B, and 5 client, or you can 5 requests coming from the 5 client, request 1, 2, 3, 4 and the 5. In these all 5 requests of client are connected with the load balancer, and load balancer is connected with the various server. In this diagram only 2 server, and server A is greater than server B because the capability of server A is higher than server B. So first you have to allocate the highest capabilities server. So you can allocate 1, 2, 3, 4 and the 5th will be 1. So let us see with the help of first will be given to the high weighted. So first will be given to the server A, and second will again given to the server A, third again given to the server A, fourth again given to the server 4 because server A having the 4 weights. So 4 incoming requests are allocated to server A, and the remaining 5th one will be given to B because B having the less capabilities as compared to server A. So according to the processing capability of the server, the load balancers are used to allocate the incoming request from the client and allocate the request to the particular server so that particular server can process according to their capability. So the capability of server A is higher than capability of server B. So 4th jobs and 4 requests are entertained by server A, and only 1 request of a client are handled by server B because the capability of server B is less than the capability of server A. So let us see the new arrival of the request. Maybe after it and some new jobs or some new requests come from the client, then how can you allocate the incoming arrived new request to the server for both server A and server B, whether the new request coming from a client that request 6, 7, 8, 9, then you have to allocate it for processing to the particular server, whether you have to allocate these new requests to server A or server B, whether you have to allocate for the high capability server or the low capability server. So let us see with the help of this animations, the job 6 coming, job 7 again coming, job 8 again coming, job 9, or you can say it is a request coming from the client, and the request 10 and the 11. So there are 6, 7, 8, 9, 10, 11 are the new requests coming from the client. Now the question is here to allocate these all new arrived requests to the server for the processing. So let us see here again the 6, 7, 8, 9, 10. Okay, so let us see, you have here first 6 will be given to server A, and 7 will be given to server again A, 8 will be given to server A again, and 9 will again given to server A because server A having the 4 weight. So 4 requests altogether allocated to server A and then move to the next server to allocate the new job arrived. So 10 is the new job arrived here, then allocate 10 request to server B, and then 11 again to server A. So this is the arrangement, this is the way to allocate the incoming request or job for a particular server, and that is allocated according to the weight of a particular server. So you can see in this diagram, server A having the heavy load and server B having the less load. Because its capability is low as compared to server A, means the server A is 4 times more capable than server B, and server B is 1 and server A is 4. So server A capacity is 4 times higher than server B. So that all about the weighted round robin scheduling. So let us here see what is the benefit and why it is used. It can be better result than the round robin algorithm. The higher weight, the larger the proportion of client request server received. So in short, you can see here the weighted round robin scheduling. So weighted round robin scheduling is better than round robin. So why it is better than it? In the case of round robin, you are going to distribute the job in the round, and some server is fail, so and some they are waiting there, so there will be problem. So just you can assign the for example, let us see one server having the capability higher and second server having the capability low. So if you are giving the equal load to both the server, at the some point of time the low capability server will be fail. So if you are going to allocate with the according to the capability, then it will be better. That's why the objective of weighted round robin scheduling to solve the problem arises in the round robin scheduling, because in the case of round robin scheduling you are giving the equal weight to both, but you are not judging the capability. One capability is low and one is high, so you are giving the equal weightage. Then in some instance of time the low capability server will fail. So in the case of weighted round robin scheduling, you are allocating the request, you are allocating the job according to the capabilities of the particular server. So in this way, if you are allocating the job request according to the capability of the server, so there is no chance for the failure, and the higher weight, the larger the proportion of the client request the server services. So this is all about the weighted round robin scheduling. And friend, you understand the difference between the round robin algorithms and the weighted round robin. So weighted round robin is the better than the round robin algorithm. So let us move to the next type of algorithm for the load balancing, that is known as the list connections. So list connection is the third load balancing algorithm for balancing the load among the various server. And you know everyone what is the objective of load balancing, so that the all requests can be treated in the same manner. So the third algorithm, that is known as the list connections algorithm. So the requests are connected to the least connected server. Let us see in this diagram, there are two server A and server B. So server A having 3 connections, 1, 2, 3, and server B having 1 connection, that is 4. So you can say server B having the least connections. So let us see here in this diagram, request 1, 2, 3, 4, 5 are connected with the load balancer, and 2 server again, server A, server B connected with the load balancer. And here the server A having the least connection, server A having the high connections and server B having the least connection, because server B having only 1 connection and server A having 3 connections. So first you have to allocate the job or request according to the number of connections. So first each connection is 1 given to server A, second to A, and third to A. Means server A having the 3 requests allocated, and the fourth one that is coming will be given to the server B, and server B again the 5. So now in this scenario, let us see again server A having the 3 connections and server B having 2 connections. Now so again you can say server B is the least connected and the server A is the highly connected. So now if the jobs are coming, new jobs, new requests are coming from the different client, and then you have to allocate it to the new to the server for the processing. Let us see here with the help of animations. New jobs are coming here, that is the request 6 come, and again the another request coming, that is the 7, and next coming is the 8, then the 6 will be allocated to the server B. Now let us see the scenario. You have 3 jobs arrived, that all are the new requests arrived, that is 6, 7, 8. Now you have to allocate this request to a particular server, whether you have to allocate it to server A or server B. So first you have to check where is the least connection, and the new arrived request will be allocated first to the least connected server. So in this diagram, B is the least connected server, so 6 will be given to here B. So 6 job request 6 will be given to server A. So just see here, and 6 will be given to. Now 2 more remaining arrived requests, then you have to allocate. Now in this scenario, the both server having the equal connections, server A having the 3 connections and server B having the 3 connections. So the next coming arrived, that is the 7 request, that will be given to 7. Let us see here, the 7 will be given to request, 7 will be given to server A, and 8 will be given to server B. So this is the arrangement of least connections algorithm. So friend, this is all about the round robin, weighted round robin algorithms and least connections algorithms, and after a short break I will discuss the weighted least connections. Friends, thank you very much.
With this note, thank you, sir. Thank you so very much for giving us this session. Friends, you are requested to be with us as we are back after a short break. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are talking in our series on cloud computing. In our previous session we discussed on load balancing as well as we talked on algorithms. So friends, in this session too we are finishing up with the algorithms and would be starting with resource optimization in cloud computing. For discussion on the topic, we have with us in our studios Dr. Mansaf Alam. Dr. Mansaf Alam is Associate Professor in the Department of Computer Science, Jamia Millia Islamia. Friends, if you wish to ask questions from Dr. Mansaf Alam on today's topic, then do call us through our toll-free number. Our number is 1800-110-430. I repeat, our number is 1800-110-430. Now, I would like to welcome our guest, Dr. Mansaf Alam, once again. Hello, sir.
Thank you, ma'am. Hello, friend. Good afternoon. I am Dr. Mansaf Alam, Associate Professor, Department of Computer Science, Jamia Islamia. Friend, before going on the break, I was discussing about the least connections algorithm for load balancing. So let us see quick review. After that, I will move for the next algorithm. In the least connection algorithm, you have to first allocate the incoming request to the least connected server, so then the move in this way. So that is the arrangement for the least connection algorithm. Now friend, let us move towards the weighted least connection algorithm. So the requests are connected according to weight of server and number of connections, then when server A greater than server B. So again, same as in the least connections algorithm, first you have to just modify the least connection by adding the weight to the server. So server A having the weight 4 and server B having the weight 1. So according to the weight of a server, you have to allocate or give the request to the particular server. In this diagram, there are 4 requests coming from the client: request 1, request 2, request 3 and request 4. And see here in the diagram, the server A having 1 connection, 1 is already, so 1 is allocated to server A. So in this scenario, the server A having a 1 connections and server B having the least connection. Now you have to allocate the request to the server A or server B. So now we have the client request 2. So whether we have to allocate it to server A or server B. Let us see here. So 2, 3, 4. So second will be given to server B because the first already assigned to server A. Then the third will be given to server A and fourth will be given to server 4 because the weight of server A is higher than the weight of server B, means you can say capabilities of server A is greater than the capabilities of B. Next, now let us consider the next arriving job, that is the fifth. Now the fifth new job arrived recently, and the next job, that is the sixth job, seventh job, eighth job. So 8 jobs. So now we have arrived 4 new jobs. Now we have to allocate it to the particular server for server A and server B. Now let us see here in the diagram, the least connected is server B. Server B having the 2 connections and server A having the 3 connections, but the weight of A is 4 and the weight of 4. So whether fifth will be given to A server or B server, let us see here. So fifth will be given to the least connected server. So B will be take the 5, that the new request come from the client, and then the 6 will be given to the server A. 7 will be given to server A because having the more weight than the server B, and then server A having the 8. So 8 will be given to server A. Now 4 jobs and 4 new requests come, and out of these 4, 3 allocated to server A and 1 for the B. So these all are the connections and the concept behind the weighted list algorithm. So now let us see here next type of algorithm, that is known as the random algorithm for load balancing. So requests are connected according to the random number generated. So first a random number is generated. According to that random number, the request coming from the client will be allocated to the server. So in this diagram, let us see here server A and server B. So first at randomly number 1 generated and given to server 1, and again the server 2 given to the server A, and the third random number generated and given to the server B, and fourth again given to server B, and fifth again routed to the server A, and sixth to the server B. So it depends on the random number generated, and that random number will be allocated to the particular server. So let us see here 2, 3, then 4, then 5 to A, and then 6A B. So this is the first round allocations of jobs coming from the client. Now let us consider for the next round a new jobs arrived in the queue, that is 7, 8, 9 and 10. Now the situation here, how to allocate the new arrived request or job to a server A or server B. Let us see here the first job arrived, that is the new one 7, and you have to allocate it to the server, to which one, A or B, where we have to allocate the new arrived server 7. So first server will be given to the server A 7. So 7 is the new request coming from the client and given to the server A. And what about the 8, whether 8 will be given to A or B? So 8 will again given to server A, that is based on the random number. And what about the 9, whether 9 will be given to A or B? So 8 will be given to B, and next term, that is the 9 job or 9 request. 9 request will be given to server B. And what about 10, whether 10 will be given to server A or server B? So definitely that 10 will be given to server A. So this is the arrangement about the random algorithm. That random algorithm is used for the load balancing in the cloud computing. So friend, these all about the load balancing algorithm. Let us see some summary of load balancing algorithm. There are 5 load balancing algorithm, that is the round robin load balancing algorithm, weighted round robin load balancing algorithm, least connection load balancing algorithm, weighted least connection load balancing algorithm, random algorithm. So these are the 5 standard algorithm. Let us one summary what are the difference among this one. So round robin scheduling, it assigns request in turn to each node or a server. And if you are talking about the weighted round robin, so it assigns request in turn to each node or server in proportion to their weight. And if you are talking about the least connection, so that is used to assign request to each node or server with the lowest connections. And weighted least connections, so assign each request to node or server based on number of concrete connections to the node or server and its weight. And the last, that is the random, for each request choose random node or the server. So friend, these all about the different type of load balancing algorithm existing in the real world, and people are treating it as a standard algorithm for the load balancing. And that all about the summary I have discussed about this. So friend, now we will move for the next topic, that is the open source load balancers for the high availability and improved performance. So many open source load balancers are available in the market, and that may be freely available, so that you can use it for your personal work or for your solving your problems in the case of high availability and the improved performance. So there are three kinds of load balance on high level. First one, hardware based, cloud based, and software based. So some few popular load balancer hardware vendors are available in the market, and you can take the services from the load balance hardware vendor, but these are very expensive, but it having the complete feature that give you the full control. These all are the expensive, but maximum feature are available with the it, so that you can have the full control. Then F5 is a load balancer, very popular load balancers vendor. You can take the services of load balancing from the F5, and TP-Link also a popular company, and that is the hardware vendor for load balancer. So you can also take the services of TP-Link as a load balancer. You can also see here Bracuda is a company, or you can say is a vendor providing the services for the load, and also F5. So these all three are available in the market. These are the vendor providing the services for load balancing. But friend, these all are more expensive, but along with the expensive services, but it having the full control and complete feature. So it will be benefit for you when you are going to use the load balancer for balancing the load among the server. Now let us see here, cloud load balancer is one of the affordable way to enjoy full features without investing in a hardware appliance. You pay for what you use. The following are some of the known cloud load balancers. So here cloud balancers are Amazon AWS, Google Cloud, Cloudflare, Incapsula, DigitalOcean, Azure. So friend, see here, load balancer is one of the affordable way to enjoy the full feature without investing in hardware appliance. So you can enjoy the load balancers affordable way to features. So load balancer features you can enjoy without any investing the heavy amount for purchasing or buying the appliances. Whatever you are going to use the load balancer, just you have to pay for it, and if you are using it, you can pay it. If you are not using it, you do not need to pay it. So you are not going to more expenditure on using the load balancing according to the requirement. As soon as required the load balancing, you can use the facility of load balancing, just pay some amount. But if you are not using the cloud based load balancer, then you have to invest more money on the hardware. So in this way it is better for you people. In the market, the various load balancers are also available, that is the AWS, Google Cloud, Cloudflare, Incapsula, DigitalOcean. But it's a low, then the cost of this is as low $20 per month. So you can enjoy after taking the services of cloud load balancer. Now let us see here, there are some free or open source load balancer are available in the market. You can try it, you can use it. That all are the open, or you can say freely available load balancer softwares. So the following are the some free or open source load balance are available in the real world, namely Seesaw, HyProxy, and Jevent, Pain Load Balancer, Balance, Netrine, and Treefreak, and Nginx. So these all are shown on the screen, all available in the market. That all are freely available open source load balancer. You can try it, you can use it and see what benefit you can get with these all free open source load balancers. So friend, now we are moving towards the resource provisioning challenges in the cloud computing. There are several challenges we are facing for resource provisioning, and how can we solve these all challenges to allocate the resources in a cloud computing so that we can process the data easily and we can improve the performance of the system. So resource provisioning, resource provision, that is equal to provide activity or resource supply to accommodate user or system. The goal: how many virtual machines are required to provision in advance, provision with reservation plan. So friend, let us see here in resource challenge, resource provision challenge in the cloud computing. So the resource provision, that is equal to provide the activity, or you can say resource supply to accommodate user system. So many resources are supplied that can be accommodated in the user system, and there is a goal: how many virtual machines are required to provision in the advance. First you have to tell about the virtual machine requirement. How many virtual machines are required for processing your data. Suppose you have to process a job, and for processing that job 5 virtual machines are required. So first you have to tell in advance that I have to use 5 virtual machines, so that will be allocated to use in the case of reservation. So 5 machines will be reserved, 5 virtual machines will be reserved for your computer because you have demanded in the advance. Now let us see here the challenges. The first challenge: more than one cloud providers and quality of service and service level agreement. This is the first challenge, that is cloud service providers, quality of service and service level agreement. So this is the challenge. And the second challenge, that is the multivariant uncertainty, for example demand, price, availability. So first here next one, the third one challenge, that is the optimal solution under uncertainty, and the next challenge, complexity of computations. So these all are the challenges in the resource provision in the cloud computing. Now let us see here resource optimization provisioning cost in cloud computing. So there are 2 cloud consume provision plan. So if you are going to consume the cloud, so a cloud provider can offer 2 type of consume provisioning plan. The first one, that is known as the reservation plan, and second one, that is the demand plan. So these are the 2 plans given by the cloud provider for consuming the resources. Now let us see what is a reservations plan. In the case of reservations plan, it is cheaper than on demand plan. Cloud consumer pay to the cloud provider in advance. Consumer pay to the cloud provider in advance. Consumer produce total resource provisioning cost. And second, that is offered by the cloud provider on demand plan. So it is costly plan, charged as pay per use basis in the case of on demand plan. And next, you can get resources as your requirement and pay the money for the resources. So cloud provider generally give you 2 type of plan. First one, the reservations plan, and second one on demand plan. Now let us see here provision for optimal cloud resources. So proposal of OCRP algorithm, it is to minimize the expected resource provisioning cost in more than one provision stage. For example, quarter plan, stage 4, 1 year plan, stage 12, 3 years plan, stage 36. So, multivariate uncertainty considerations. So, using multi-stage recourse that optimal solutions is obtained by formulating and solving stochastic integration programming, and the techniques to solve OCRP, that is deterministic equivalence Bender decomposition sample average approximation. So, many experiments show that OCRP can minimize the cost under uncertainty. Now, let us see what is OCRP model. So, see in the diagram here, physical server, that is the here physical server, this is the physical server, virtual machine, and this is the cloud, and this cloud having the cloud provider 1, cloud provider 2, cloud provider 3, and this is the OCRP model. This is known as the broker of the cloud, and this is the consumer of the cloud. Here is the virtual machine. This is the repository of the virtual machines. And so, let us see how companies are optimize cloud cost. So, monitor utilize the right, that is the 45%, and this is the diagram for SMB or enterprise. So, for SMB that is 45%, for enterprise is the 45%, and automate shutdown of the temporary workload, then 34%, that is for enterprise, and 28% for the this one. So, for see here in the purchasing AWS RISE, that is 28% in the enterprises and 36% for the SMB. That is the source RightScale 2016 State of the Cloud report, and you can also see use of AWS Spot instance, that is the 14% in the case of enterprise and 18% in the case of SMB, and Google primitive virtual machine, that is the 4% for enterprise and 3% for SMB. Now, let us see here resource optimization algorithm in cloud computing. So, these all are the standard optimization algorithm. First one is the genetic algorithm, that is GA. Second one, that is the ant colony optimizations, that in short ACO algorithm. Next, particle swarm optimization, PSO algorithm, and next bacterial framing optimizations, BFO algorithm. These all four are the standard algorithm for resource optimizations in the cloud computing. These all also used in the different field, but it also used in the cloud computing for resource provisioning. So, let us start from the genetic algorithm for resource optimizations in cloud computing. First, understand exactly what is genetic algorithm. So, resource allocations optimization is one of the most challenging problem in cloud computing. So, due to large number of activity execution alternatives, genetic algorithm is used to optimize the resources in cloud computing. So, let us see here what are the benefit of genetic algorithm. It is easily understandable concept. It is modular and separate from applications. It support multi-objective optimizations for noisy environment. It is easy. Answer get better with time. It easily distribute inherently parallel. So, friend, let us understand it exactly what is genetic algorithm. In the case of genetic algorithm, first data is populated and then bifurcated. Let us see see an example. Suppose in a country people want to generate and grow the honest people. So, first you have to divide the whole population in two parts, bad man and the good man, and then tell the good man to increase your generation. In this way you are creating a populations and then finding the best solution, then you can find the offspring, and then in this way you can use this algorithm in your cloud computing to resource optimizations. Friend, let us move to the next algorithm, that is known as the ant colony optimizations. In short, you can say ACO. So ant colony optimizations algorithm is a probabilistic technique for solving computational problems which can be reduced to find good path through graphs. Artificial ants stand for multi-agent method inspired by the behavior multi-agent method inspired by the behavior of real ant. This algorithm is used in cloud computing to optimize the resource. Just it work on the principle of ant. So experiment for double bridge. So see here, there is a ant and there is a food. So here some ant come from this side, some ant come from this side. Like finally all got the shortest path from this side and they come to reach the food. Now this is the algorithm and flow chart for the ACO algorithm. Now advantage and disadvantage of ant colony optimization ACO algorithm for load balancing cloud computing. So the advantage, provide dynamic and effective load balancing. Disadvantage, ant can move in only one direction, it can not roll back. Now let us see the particle swarm optimization PSO algorithm. So particle swarm optimization is a population based stochastic optimization technique that is developed by Dr. Ewart and Dr. Kennedy in 1995, that inspired by social behavior of bird flocking or a fish schooling. PSO shares many similarities with evolutionary computation techniques such as genetic algorithm. So particular swarm optimization process. So population is initialization in hyperspace, evaluate individual particle fitness, velocity is modified based on previous based and global or neighborhood based. So terminated based on some condition and to the next step. So friend, let us see, this is the flow chart of PSO, and now the last algorithm for optimization, that is the bacteria Ferengi optimization BFO. So bacterial Ferengi optimization is a recently developed nature inspired optimization algorithm which is based on the Ferengi behavior of E. coli bacteria. BFO has been applied successfully to some engineering problem due to its simplicity and ease of implementation. So BFO algorithm is used to optimize resource in cloud computing. So there are certain steps in the BFO. Chemotex simulate the movement of E. coli cell, swimming the tumbling via flagella, swimming group of E. coli cell arrangement themselves in a traveling ring, reproduction and eliminate the disposal. Friend, this is the reference, and thank you very much for listening my lecture. I hope you have enjoyed this lecture. Thank you, ma'am.
With this one, thank you, sir. Thank you so very much for giving us this session on cloud computing. Friends, we know that you have questions and you want your questions to be answered. So if you're not able to talk to us today, then you can write to us at info.cc@nic.in. You can post your questions as well as feedback. We'll try to give answers to your questions when next time Dr. Mansaf Alam visits our studio. Till then, keep watching us, keep writing us. We are going to meet again soon. Thank you. Thank you so much.
Thank you.